Hello Cherno, big fan of your code review series here. Recently I've made a game using SDL and C++ for an application, which I didn't pass. In my head, the architecture and code was good enough to pass, so I don't know what I could have done better. Help me. Today, we're gonna take a look at this person's code and see if we can figure out exactly why they wouldn't have passed an application. Don't know what kind of application this is, like university, school, a job, but I'm gonna try my best to help this person here. I'm gonna try and just nitpick this and pretend that I'm like the harshest reviewer ever, and we're gonna see if we can't figure out exactly why this person failed. Okay, so here's a link to the repository. Ors like game done using C++ and SDL. I don't know what an Ors like game is. I don't know, is this before my time? Looks kind of cool. C++ and SDL, I can already see it's actually using pre-make, which is pretty good start. Here it is over here in Visual Studio. Let's go ahead and run it. Builds out of the box, no problem. Nice little title. Missing an icon, that's probably why you failed. No, I'm kidding. We can hit the play button. Okay, so how does this game work? Because I don't think I've ever played anything like this before. Okay, so I think it's clicking. So you can break tiles that are like kind of contiguous in color, right? So if there's multiple tiles next to each other that are the same color, it seems like you can break them. And I guess the idea is not to get to the end zone, because if I get to the end zone, yeah, I lose. Okay, and you can manually push as well. All right, cool. Now, obviously I have no idea what the rules of this game are, so we're not gonna focus on like the rules. We're just gonna try and focus on the actual C++ code and see what's up. Okay, so I found this main file. Let's take a look at it. And again, just remember, I'm gonna be like the harshest critic here. I'm really gonna nitpick here. I mean, I don't know yet. Maybe the code is actually just rubbish. I don't know, I haven't looked at it yet. But the idea here is gonna be everything that could have gone wrong. Like when someone reviewed this code and was like, nah, this person I don't want, they're gonna fail. I'm gonna try and figure out why. So first of all, like this seems pretty innocent, but I can already point out, this is kind of fun. I can already point out like 50 things that are wrong here. Okay, maybe not 50, but let's take a look at the beginning here. So unique pointer game. Why is game a unique pointer? Right? If we take a look at game, sure, that's like your main kind of game application class that just has the rest of the program in it basically. And it all stems from this. You know, it's got like a few, well, it was got like 3 shared pointers, an int, and like this save data struct, which isn't much memory, right? So why is it being heap allocated here as a unique pointer? Instead of doing this, stack allocate. Always prefer to stack allocate. You don't need to heap allocate memory in this case. And again, if you can avoid heap allocating memory, you always should. The basic reason why is because it just costs more to both allocate and access that memory. So even though wrapping it in a unique pointer is a good start, like it's better than if you had just had a raw pointer like that, because that means you manually need to delete it. So I'd have to call delete game versus obviously having it wrapped in unique pointer means that the destructor of unique pointer at the end of the scope will call delete by itself. It still has to call delete. So there's still that extra operation of like, okay, I have to free this memory manually. I have to put it like, you know, back in the free list, deallocate, do all of that kind of overhead that comes with the deallocation and obviously the actual allocation in the first place as well, versus just like moving a stack pointer and also having that memory readily accessible in the stack because it'll be hot in the cache versus heap memory who knows where. That is the basic principle. That is the basic rule to follow in C++. Does it apply in this case? Like in the real world, you know, if this was left as a unique pointer like it is now, is that actually a downside? Objectively, I would say no, because if you're not going to notice a difference. If this was like stack allocated or a heap allocated, unique pointer or just a stack object, in reality, this is the sad thing. You're not actually going to see a difference. But someone looking at this code might be like, okay, well, since there's no reason for this person to have heap allocated this, maybe they just heap allocate everything and they don't understand basically one of the core things about C++, which is memory. I mean, the core, probably the most core thing in programming in general. If I had to name one thing, it's probably memory. Memory is the resource that you manage, that you handle. Everything revolves around memory, including the fact that your actual program is loaded in memory. All of the CPU instructions are in memory. Memory is everything. So that would be the first thing. The second thing I can see immediately is this while game running. Why is running public? Running is just a public bool. Why are you here? Sorry guys, the cat is back and the cat is very needy. Alivka, for those of you who remember. This is Olive, or Alivka, technically. So she's just gonna chill here. She's gonna help me get to the bottom of why this code failed. So why is running just public, right? And it's also sitting kind of amongst like the rest of these functions, which is a little bit weird to me. But like the general way that I would expect this running variable to work is the fact that it should probably be controlled from one point. And that's probably from this game. Game is like the application, it's the authority to be like, you know what? running is now false. I'm gonna stop the game. By making it public like this, it's a little bit weird because I could obviously do something like that. And do you want to allow that? Do you not want to allow it? I'm not saying that you can't allow it and that's strictly wrong, but it is just a little bit weird. It's just a little bit, I guess, atypical. People don't usually do this. Usually you would have a getter called isRunning and you wouldn't really have a setter. You might have something like game stop, right? So you might have a function called stop and that would set running to false as well as do any other shutdown behavior or do anything that might need to happen in order for the game to actually stop. But having running as a public variable, you know, just might be a little weird. Someone reviewing this code might look at that and be like, that's a bit weird. Include IOStream. You're not using IOStream. That's an unnecessary include. That shouldn't be here. Are you guys enjoying how like pedantic I'm being? I kind of am, to be honest. Now, speaking of enjoying yourselves, don't you guys just love learning? Don't you just enjoy it so much, especially when it's just presented really well? Like, for example, the amazing computer science and math courses on brilliant.org, the sponsor of this video. Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics, everything from the foundational computer science stuff. If you've never done any programming and you don't even know how to think like a programmer, they have courses specifically for that. But it's not just content that you just sit back and watch and zone out. It's content that you interact with, that you engage with. It's presented in this really beautiful visual format that's honestly quite fun to get through, and you'll constantly be quizzed on the material that you're going through to make sure that you're actually learning stuff. Once you've got a grasp on the basics, you can move on to their Python courses, which will teach you how to write a real application in Python. And then of course, there's math. Math is just so important, and I think it's so important to teach it visually with like these widgets that you can play with to see how numbers work, and being able to interact with that, being able to see that visually is, in my opinion, by far the best way to learn advanced topics like calculus. Whilst again, being quizzed along the way, having like daily challenges you can complete, you'll honestly be surprised at just how quickly you'll learn with this way of teaching. And the best thing about Brilliant is that you can try it for free for 30 days. They have a 30-day free trial. Just go to brilliant.org/Cherno. Link will be in the description below. You don't have to take my word for it. Try it out for yourselves. You can use that trial to explore their entire platform. And if you do go on to like it, Brilliant have been nice enough to offer 20% off a premium subscription. Huge thank you to brilliant.org as always for sponsoring this video. Okay, anyway, I think I'm pretty much done with this main like file. I mean, like, what else is there to say really? I guess you could get rid of this. The thing with the main function, by the way, guys, is in the C++ standard, it states that the main function that returns int is special. I'll try and put the actual reference to the place in the standard up on the screen. The standard's actually not free to access, which is fun, but I'm pretty sure you could just Google this part and it'll tell you. Even though the main function returns an int, it's special, and it doesn't actually explicitly need to return 0. If you want to return something other than 0, of course, you need to write that. But if you're returning 0, you can technically omit it, and that's acceptable. Not saying you should do this, not saying me as an interviewer would look at this and be like, he's got return 0 here, what an amateur. Because if anything, this probably makes it a little bit clear that your return code is 0. Not that it's a big deal to include your return code, to be honest, for a program like this, for example. But anyway, maybe this shows that you know more C++, because a lot of people don't know that. So I don't know, maybe you want to like flex a little bit, if you can call that flexing for your interview. I don't know, man. Maybe that was the reason you were failed. I don't know. All right, let's have a look at what game does, because I'm getting sick of that file. Yeah, like, you know, I'm going to try not to get into opinionated stuff here, because like I would definitely write this differently. What are you doing, man? Again, these just being here public for some reason, along with all the functions, is a little bit weird. I like to put separators in like this. I like to have all of my variables, you know, actually these two are also variables, like grouped down here. I like to have m underscore, like this is all opinion stuff. Lots of people don't do this. Lots of people are excellent programmers. Like you don't need to follow my convention. But I will say that when you do things like this, like if I see someone using m underscore, it might seem really insignificant, but it shows that they potentially understand why it might make sense to like kind of segregate and separate out private member variables from, say, things like local variables. When I see someone just writing variables like this, and especially if they're kind of all over the place and half of them are public, it's not necessarily that the code is functionally bad, but to me, it just shows a little bit of a lack of experience. And again, I could be wrong, man. It could be a senior engineer who's been working for 20 years could write this code. Sure, maybe it works really well because obviously the CPU is not going to care. The CPU is not going to care what's public. The CPU is not going to care about your naming convention. It's not going to care about your lack of dividers and the fact that public variables are intertwined with public functions. None of that matters. So it's not going to make any kind of difference to the end result, to the running code. But as a human reading this code, it just seems to like kind of just communicate a bit of a junior programmer inexperienced vibe. That's all. And to be honest, I feel like just the reason for that is that professional teams of software engineers, like in C++, you know, at least in my experience, like where I've worked and what I've seen, they just tend to write code differently. And so I guess what I'm getting at is, because, you know, like once I started working at EA, like on the core engine team, I started using M underscore. Like I didn't use that before. I never would have thought to use that before. But then when I started working at EA, I was like, I kind of like that. That's cool. Because that didn't really get taught like in university or anything. I was like, whatever. But I picked it up working as a professional. So that's kind of what I'm getting at here. I'm just saying that like sticking with a code style, having like a convention and being a bit more organized kind of just shows that you're experienced. Because the fact of the matter is, if you are a professional and if you're a good programmer and if you're writing code 8 hours a day every day, you know, like as a full-time job, you take organization and like things like this fairly seriously because you get to see the impact that being disorganized potentially has, as well as the fact that you have like a technical director or someone like a team lead enforcing a particular style. And then you just kind of get used to it. All right, let's take a look at the actual game thing. I'd probably undo my changes as well. Okay, so we got a bunch of, okay, cool. So this is another thing, right? So the variable initialization situation immediately catches me a little bit off guard because last frame time is initialized here. Like, why isn't it initialized here? Yeah, just set it equal to 0 here. Speaking of which, why the heck is this snake case? You've got camel case like everywhere else, but this is snake case. Why? Why is this not just written like this? See, this is what I'm talking about. Also, why is it an int? Last frame time being an int, I don't understand. Like current ticks, so it gets set to current ticks, but that's a float. Convert milliseconds to seconds. Yeah, because you're dividing by 1,000 and this is presumably in milliseconds. So this is now in seconds, but then you just lose the fraction of the second and you round it down to the nearest second, and that's your last frame time as an int. That's also weird. Like, why is this not a float or a double? I like it's like the fact that it's an int is just really weird. As well as the fact that it's snake case. That's probably the first thing I would notice. Why is it snake case? Anyway, if you did want to initialize things in the constructor like this, that's the other thing. Usually you'll see people actually initialize it like that. And the real reason it's not gonna really matter in this case because it's gonna be an uninitialized int and then you're gonna initialize it here. But in a lot of cases, the reason why people prefer to initialize stuff up here in this kind of initializer list, I don't actually kind of forgot, it's constructor initializer. I forgot the actual technical term for it, but this section over here is because a lot of the times when you have something like, you know, like a class or even this shared pointer, which obviously a shared pointer is a class, what will happen is this obviously is a valid way to create a shared pointer, right? Because you're just creating it with a parameterless constructor. You've got a constructor, it has a default constructor that has no parameters, and you've constructed that object. And then later you're reassigning that object to another object. You know what I mean? So what's happened here is with current state, for example, actually that's a bad example. What do we have here? Render, right? Render is a shared pointer. You've actually created the object twice. You've created it here once with no parameters, the default constructor, which again, probably didn't take much time, many CPU cycles, but still you have constructed that object. And then you're discarding it. So you're calling the destructor, you're getting rid of it, and then constructing a brand new object over here, which then kind of gets assignment operated into this render thing. That is obviously technically a waste. If you instead had just written render and then had this make shared up here, you know, again, this is definitely a micro optimization that's not going to have any real world bearing, but it again shows a little bit of a deeper understanding of the language and how it works, right? The fact that if you do this, then you're not going to get that default constructed object anymore. Instead of default constructing it here first and then reassigning it, it's going to construct it just once up here. And obviously you don't have this part here. So that's another thing that I would probably get into the habit of doing where possible. But again, like, you know, I probably wouldn't pick on that too much. Maybe if I was critically reviewing this code, I would be like, why is this snake case and why is it initialized here? Just make it like stick with the rest of your convention and initialize it here. All right, speaking of which though, we have all these states here, which I'm becoming a little bit suspicious about. So we have these states, which are, okay, so they contain kind of input observers just so that they can get, okay, I don't think there's enough time like in the world to cover everything that I would probably change or potentially pick on in this project, because there's just a lot to talk about. Like even this fairly deep game hierarchy, which really comes down to having input observer as the base class, just so that I guess you can receive events. Like this is probably something that people could nitpick on. And the reason why is because this whole like hierarchy of C++ classes, it's going to entirely depend on who is looking at your code and reviewing it, because a lot of people out there hate object-oriented programming. And this is like this whole deep hierarchy, because it's kind of unnecessary, it really does create like this just burning hatred inside some people. Not in me, because I'm a little bit softer. Like I don't think that it's a big deal. This isn't a terrible way. By the way, you also don't need these semicolons. This isn't a terrible way to like write something like this, because fundamentally, like if we look at Hazel has this thing called a layer, and sorry for my awful writing. And from layer, we have things like, you know, game layer or whatever, or we'd have like editor layer for the level editor. And layer has a virtual function in it called onEvent. And onEvent is a function that receives like an event object, and then together with something called an event dispatcher, you can basically find out what the event type actually is and forward it to a custom function or a lambda that you kind of set into the dispatcher when an event of a particular type gets received. I kind of like this system more. It's actually kind of similar to this, but I like it more. And the reason why is because, first of all, and I think I'm going to try and be brief here just because this could go on forever as well, but you have a single virtual function called onEvent, and that's it. Because the amount of events that you can have can really grow. This is a specific game, which clearly seems to only have quit and like mouse left click events. That's fine. But if you build something a bit more serious and suddenly you want keyboard input, or suddenly you want like just the mouse location as an event, or you want, I don't know, like a window resize or a minimize event, like there could be lots of different events that you have to keep adding virtual functions to the base class and kind of growing this whole thing, versus here you just add different event types and they're all kind of encompassed in this actual event type. But then also the difference is that typically in an application, you have like one or two layers. So you only have like the editor layer, which is kind of like the root of your specific application, like in Hazel, and everything stems from that, which means that if you have another class that needs to receive events and it's inside editor layer, then that class, you know, that object that's inside editor layer, in editor layers onEvent, which you've overridden from the base class, you'll call that object's onEvent, right? So it kind of all rains down from here. Versus the fact that inside game, you create all of these different states, and then they kind of all are rooted in game state base, and they all have this input observer, which have their own event. So to me, it's just a little bit more confusing to spread it out like this. And what it unfortunately ends up doing is just creating these like super deep class hierarchies for pretty much every object in the game. Okay, so in-game state, I'm guessing is kind of like, this is the, I'm playing the game. So these game states, how are they actually set? So we have all these, like they get instantiated like here, and then I'm guessing that that's what current state is. Current state is just assigned to like one of these basically. And I guess it can change. So how does it get assigned? So switch state, yeah. And then we pass it a new state, sure, some like housekeeping. And then basically we just set current state to new state. And that's like the one that we update. And then in the constructor, you can see switch state is called with menu state, just so that when we play the game, obviously we're taken into like the menu. Now at its core, I think that's a fine system. Like it's pretty like typical, I would say. I just don't like the way that you've actually laid it out though. And the reason why is because, again, scale. Scale is another really important thing in programming. And what I'm talking about there is what happens if you need to like times 10 this, right? Like what happens if instead of 3 states, you have 30? Is that gonna happen? Probably not. And again, if my sole purpose was just to write and ship this specific game, then yeah, like I guess it really wouldn't matter. But if I was reviewing this code and I wanted to see if this is a true reflection of this, like if this code is supposed to be the best example of what this programmer is capable of, then obviously I'm going to look at it a little bit differently. I'm like, okay, well, if they have a state system in their game, like how would they implement that? And this is just like, it just leaves a lot to be desired because, again, the scale. What happens if you have 30 of these? I think it would make much more sense for these to actually be in some sort of data structure, right? So instead of these just floating around as public variables, all of these states should be somewhat better organized. Now, the good news is that, again, you have a base class here called game state base. So you could have like some kind of map from like what type of game state am I in to an actual shed pointer of this game state base type, which obviously would accept all of these because at the end of the day, it also doesn't matter exactly what type they are. You just need to know, okay, menu state, set this one. Loose state, set that one. Like in-game state, set this one, right? It's not like you're using any of these states. You're only using them in the context of current state. Once you've created them, you fall back to current state. And what is current state? Obviously game state base, because it has to be any of these three. So I think storing them kind of loosely like this is almost a disservice to the fact that you're treating it later as the base class anyway, or as one of the base classes, because I guess the base class of game state base is actually input observer. Necessary? No, not necessary. Completely not necessary, but it does show that you have an understanding of like, okay, how would I sort this out if this was more serious? How would I make this in just a bit more of an organized way? Okay, I kind of want to get into like some gameplay. I guess we can look at rendering briefly. Should we look at rendering? Okay, so there's this thing called a menu renderer. So what's the, whoa, okay. Oh, hang on a minute. Bro, configs.h. Configs.h is a whole bunch of defines, right? Oh, yeah, I think that's gonna get some hate. I don't think this necessarily deserves that much hate, but like this could definitely be improved. Defines you should, in C++, I would probably honestly very rarely use any kind of defines, unless like, you know, if there's specific macros that do things, even like a lot of people will probably look down on that as well. But I think it's okay in some cases because it can drastically shorten your code. However, these are just constants. And when you have global constants like this, using defines is really not something that we've probably done for the last 20 years or so. And the reason why is because defines are simply, well, they're just preprocessor copy and paste, right? So wherever window width is used as a variable, such as over here, like what will happen is the preprocessor will just grab this and it will just put it in here, right? It's not like a real variable. It doesn't have any actual memory address or storage. You can't really do anything with it either, because again, it's not like a variable. Like for example, you can't really like debug it even, or like reference like its memory address. There's so many limitations because fundamentally it's not real. Like you've literally written something like that. Like, would you write code like this? Probably not. And so because of that, this really isn't much better apart from the fact that it's just defined in one place. Instead, what you should do is a couple things. So first of all, with these guys, these are just const char strings that are stored in read-only memory in your program. Meaning that if these were simply const chars, like it's the same thing. It's nothing changes. It's literally the same thing. It's just that you have an actual variable that you can refer to it by. With things like window, right? Because window has a lot of things. Now, I don't think you have a window class. You have a game class. But what you can do is you can just make a struct called like window settings or window specification, right? I'll call it settings because you've called it settings. And it can just have all of these guys as, again, just like normal variables. So I would, for example, create a uint32t called width, which, you know, you could just set to that. Same with height. Title could just be like a const char. So basically this is what it would look like. Now the advantages here again are this is grouped in here. So basically this is what it would look like. I've just done the rest of the variables. Then you would have to store this somewhere. Now you could just store it in configs.h. I'd probably just write like inline window settings. I don't know, like maybe you could do G window settings if you wanted it to kind of be explicitly like defined as global, and you would be communicating that to the person reviewing your code, the fact that you know that that variable's global because of your convention. And obviously if you wanted like it to be const or whatever, you could mark this as const. You can make all of these const as well. But again, they're real variables with real types. And to make it even better, they're grouped over here. And you don't have to worry about like, oh, is this name in use or like, it just fundamentally makes them a lot more real. Now you could also just have your window settings stored in game. I probably would maybe do something like that. And you could even have them just public up here. You could have a struct called window settings and then the actual like variable of that could just be here. here. You could have like your little window settings and your convention written over here. It doesn't have to be static or whatever, assuming there's one version of game and it has these settings. Now, just to stick with the global example, because it's a little bit easier, you would then go into like menu renderer, and instead of window width, you just have G window settings width. And again, if we're being like super pedantic here, people might look down on this being global. So the better option would probably be to like have it in your like game settings or in game fundamentally, like I showed before, because that way, like it's, you know, it's not just floating around in global space somewhere. It's actually tied to a specific instance of this game and it reflects its settings. So you could definitely argue that that's better than just having it global. Though again, for a game like this, like it's not really going to matter in the real world. But anyway, this approach I would say is objectively better than having defines. And I'm sure that anyone reviewing this code would probably agree. If you don't, leave a comment below. But yes, definitely prefer to use real variables. Vector over here, little buttons vector, is being passed by value. That's also a big no-no, right? Because what's happening is that this entire vector of buttons is now being copied. And a vector contains a heap allocation that reflects the actual buffer of memory that it has, right? That has every element of your array. So every time you call update and render, which, okay, so yeah, this definitely is horrific. I actually didn't even read the name of this function, but every single frame, when you call update and render with buttons, you're copying an entire vector of heap allocated memory, right? Just to kind of go through all the buttons here. So the way that you fix that is you pass it by const reference, which again would have zero effect on the code that you've already written. You simply change the code to this, and that's it. That's the only change you need to make. And suddenly you're avoiding a heap allocation. So honestly, I would say that's pretty high up on my list. I think that's a much bigger deal than all of these kind of defines, because that actually is going to have an impact on the running program. Whereas the defines obviously are not. They're just more of a, like an actual code thing. Okay, so what else do we have? Yeah, so, like, I mean, same with this, like define lose title, you lose. Like why? Like it's weird because like you haven't defined these things, right? But you specifically wanted you lose to just not be like this. Like why? And if so, like why not just make it a variable in the class? You know, like you could have just made a little const char over here or a string. Why is it a define? So that definitely needs some thought, I think, on your part as to why specifically you've decided to do this. Because again, I would just kind of prefer not to do preprocessor things like this if possible. Okay, game renderer. I suppose this might be the last thing we look at. Yeah. Just defines, just all of the defines. Why are these not variables? Why are they defines? It's so weird. You know why it's also weird? Because these are like, okay, so these are positions of UI elements, right? We have that push UI, which is that like, you know, push button, if you remember, that we had in like the bottom right corner. So specifically, you know, this person has decided they want it at window width divided by 1.2f. Okay, so like, I guess 20% in from this side. Well, I mean, not quite 20%, but close enough. So you know what the great advantage is of this? Like while you're making this game, if this was a variable, you could have just like, I don't know, exposed it to the UI itself so that you could actually tweak the position of that UI element while running your application. Because what I'm guessing you did, if you were dealing with these defines here, is you'd probably run the application and be like, oh no, that's too far like to the left. Let me make it a little bit closer like to the right. Change this, recompile the whole program. And that's the only way to do things, because again, guess what? This is not a variable. It's something that literally gets kind of evaluated and put into its place before compilation even happens, because it's part of the preprocessor. Like that's kind of wild to me. Like I really don't like that. And just seeing all of these things here, like just especially because with my syntax highlighting, they're all kind of like purple pink, like, oh, definitely weird. Okay, so draw rectangle. This fooled me. So this looked like you were dereferencing this or something weird, but that's not even a pointer, but it's actually just misaligned. So that's fun. Minus points for that. Okay, then you go through buttons, render buttons, just render a bunch of rectangles, which that's just SDL stuff. Like, oh, okay. So your curly bracket convention here is next line. Your curly bracket convention here is same line. Why? You gotta be consistent, man. Someone like that immediately, like it again, it sounds so stupid, but what it's not it's showing experience, because I feel like no experience that would irk an experienced programmer. They'd be like, that doesn't sit well with me, bro. I gotta do this. Or if they're weird, I gotta do same line, like whatever, you know? By the way, to all of you same liners out there, I actually used to do same line. Back when I programmed Java, I started with Java before I went on to C++, and I used to do same line. So it's okay. Like, I think there's enough love in the world for like everyone, but the idea here really is to just stick to like having both of these things randomly like this, like again, just shows that you're just not very experienced, or you're just, it's hard to say that because I'm sure that there are experienced programmers out there that, yeah, really don't care. And that's fine. I mean, I would say they're probably in the minority, but I'm sure they exist. But it's just if someone's like looking at your code and they see that, more often than not, I think they're going to be like, that's weird. This guy just doesn't pay attention to detail. Or he just like, he doesn't stick to a convention. Like it's just not a good look. It's kind of like making spelling mistakes. Like if you were like, I don't know, an English teacher or like someone who had to write documents of any kind. Like if you're like a lawyer or something and you're just making spelling mistakes, like that's going to look weird because you're expected to kind of have this attention to detail and to be organized and to stick to whatever your team's kind of rules are. Okay, just looking through some like board logic stuff as well. I like the fact that you're using size T. So that's another thing that I noticed. When I compiled this, there were a lot of warnings. I don't know if I've still got, no, I don't. But you generally want to avoid warnings, especially in code that you've submitted to be reviewed, right? And one common thing that I see is people just write int here, whereas like for a vector, the size is going to be the size T type, which typically is a 64-bit unsigned integer. And so having a size T here is in fact the correct type, and that's going to avoid like a comparison warning being generated by the compiler. So that's really good that you've got that there. I think funnily enough, that's another thing that shows me that you have a bit of experience, because the more inexperienced programmers would just write int. If I'm trying to be a bit more pedantic as well, logging, you know, you could have used a logging library or something that you could at least disable. Like, so this would be an appropriate place, I think, for a define, like for a macro, where you could have had something like a log, and that way you could strip that from release builds easily. Because I did notice while playing the game, like that there were a lot of log messages coming in, which, you know, obviously are kind of more like debug information that probably shouldn't be shared with like the actual player of the game. So it just shows that like maybe you've never taken an application or a game from the beginning to the actual end to a shipped state, because you don't even think about like, you know, what does this need to be a polished release? Like, what do I need to strip from the code base? Like, for example, log messages that we used for debugging. Hack break every block. Okay, well, see, like hacks can be defines. Sure, why not? We'll let them be compiled in. If they're like compile time constants, and you definitely want to, like, for example, make sure that in release builds or distribution builds, all hacks are disabled and you want to strip them, yeah, sure, whatever. I'll allow that. Have a define. Yeah, look, like I honestly don't have much else to say about it. This file's pretty good. This file almost seems like it was written by someone else. And that's such a mean thing to say, isn't it? You know what? Maybe it was. Maybe that's why it's all like same line. Maybe this was copied and pasted from somewhere. Okay, button.cpp is empty. So I've just found this as well. Like this should just be a struct. I don't think you have any structs in your game. Just make this a struct. If everything here is gonna be public and like you're kind of more treating it as just like a group of data, a group of variables, like I did with like those window settings, just make it a struct, right? That's another thing that kind of shows that you're a little bit more experienced. I feel like I'm giving you like the quote unquote experienced programmer cheat sheet, and like how if you just follow like this guide, like you're gonna make your code like artificially seem like it's like just from an experienced programmer. I bet that's the thing though. Like you could probably just like follow like some style guide and make your code just seem much better than it actually is. I secretly do that all the time. All right, and then finally, let's take a look at input handler. Again, just all over the place. I hate this. So this is the header file, right? This almost seems like it was written by someone maybe coming from Java or C# or something, where everything is in one file, right? So you would just kind of have like variables, like functions. Like, I mean, I used to put all my variables up at the top anyway in Java, but like you can have variables and functions and everything's all implemented. Everything's in one file. In C++, like I really think that kind of organization, like the kind of separation is really important, right? Because you have just built into the language the separation of CPP files and header files, right? So what I'm talking about here is handle event. Like, how would I write this? So first of all, register observer, like, and remove observer. Why are these not implemented in the CPP file? Because you've got handle events implemented there, right? So it exists, but it's just got this. Why? Grab this, right? Put it over here. So I put this like in input handler. This is going to be just like this. Same with remove observer. All right, we're gonna slap that over here. And now this comes down to this. So now, immediately this is just easier to read, right? Because you can kind of see, but then move that variable to the end, make it like private. I actually don't know. Maybe it needs to be public because of some like specific reason. And also like, why is it just raw pointers? That's another thing that's a little bit weird. I feel like this probably should be shared pointers, maybe, because you're using shared pointers everywhere else. So therefore, if you're using raw pointers, like either you're kind of using it maybe as a weak ref, like as like a weak pointer, weak ref kind of situation, where you want to just have a reference to it, but you don't want it to be owning. So you don't want it to prevent it from dying, but in which case I would just use like a weak pointer. That's what they're for. So like in general, there's very little reason to like use raw pointers as like class instances inside like a vector. Honestly, can't think of any reason why you would do that. But like check this out. Doesn't this just look better? Am I wrong? Like, doesn't this just look much better, much more professional, much easier to read for everyone? So yeah, anyway, those were basically my thoughts randomly. This is my first time reading this code. Like maybe if I thought about it more and wasn't doing it on the fly, I'd come up with potentially more meaningful things to say, but on the surface level, that's what it seems like to me. And I feel like if it's a job interview or if it's like a job application and there's lots of like, there's lots of applicants coming in, really they might just have like the person reviewing it might have 5 minutes to just check out your code quickly on GitHub. They probably aren't going to run it like in Visual Studio like I just did here, right? They're just going to check it out quickly. And I feel like these kind of superficial things that I've talked about here, they actually do play a big role. Because if you only have like 5 minutes to take a look at some code, like what are you gonna do? You might not necessarily reject this person straight away, but you might like move them, you might rank them lower and be like, okay, if there's really no one that seems a lot better than this, I will revisit that code and look at it more deeply. But again, they might dismiss you simply because of these superficial things. It's not fair, but that's life. Life is not fair. Anyway, let me know what you guys thought in the comments section below. Do you want me to do more of these? I do get quite a lot of emails with code like this and with requests like these. If you guys want to email me your code, then you can do so. Just email it to chernoreview@gmail.com. There will be that email address as well as some instructions in the description below. What did you guys think of this code? Again, I don't actually think it was that bad. Like the game worked, it functioned. There were no like obvious problems. I think actually this is probably a memory leak now that I think about it. Actually, so register observer, where does that come from? Okay, so game register observer is, okay, so yeah, the way that these observers get registered here is they get the raw pointer from an actual shared pointer. So yes, I'm right in the sense that they are kind of trying to use this, if I can find it, they are trying to use this like a weak pointer. But the problem is it's not that safe because you just have a pointer, you've got a memory address to something that is like, you're not owning it, which means it could get deleted and you might still have it. And if you try and access it, like you're accessing freed memory and that would cause a crash. So the way to go here is to look up something called a weak pointer, std weak pointer, because that's basically like the more professional, the more kind of safe way of doing what you're trying to do here, because you can actually check the state of the pointer before you like say access it to make sure to just be aware of the fact that like, is this still valid or not? But yeah, back to the conclusion, like I didn't think this code was too bad, but all of these little like superficial things that seemingly don't matter definitely add up and might show someone who's just like got maybe a couple of years of experience versus a candidate who might have 5 or 10 years of experience. And generally speaking, of course, this might be the difference between someone who gets the job or passes the application and someone who does not. Anyway, thank you guys for watching. I'll see you next time. Goodbye, and good luck to you in the future.